I'll stick to English because that's the most comfortable with you. All right. Okay. So our reference book for this particular chapter is going to be the book Devore, chapter number 1, which is introduction only. Okay. All right. Okay. So, all the basic things, mean, median, mode, and all the standard deviation, different pictorial measures, all of these things we are going to discuss in this particular chapter. Okay. So let's start from the very basics. First of all, let's try to understand, what's the purpose for studying statistics, to be honest. Why are we studying statistics? So what do you think? What is the purpose of all this? What is the purpose of so many courses in econ for statistics? So any comments that you might have would be helpful here. So the basic logic that we have is, most of the times in real world also regarding, we have to take multiple decisions. We have to take multiple decisions in different domains, whether it's government, whether it's related to our own life, whether it's work or anything for that matter. It's your health, it's your education, anything. Everything requires some decision making, right? And most of the times we do not have all the information that is available to us, right? If we would have had all the information, we would have made the perfect decision. But in real world, there is no such thing as perfect information, right? There is always some uncertainty going on. There is always some information that you do not have. So because of that uncertainty, you have to make those decisions knowing that there is uncertainty, right? So what do you want to do? You want to gather some sort of information somewhere and try to make decisions based on that, right? So like, let's say government is running some policy and it's trying to make some policy for all the people in Delhi, right? They can't talk to everybody in Delhi and know what they want, right? It's not feasible. First, it will be very costly. Second, people will not be available. Some people will be at different places at different points of time. It'll be a very long process. We have to make quick decisions. Then how do we go about doing all of that? So rather than gathering all the information, we try to pick some few samples from Delhi. We try to collect a representative sample. Okay. So like some people from North Delhi, some people from South Delhi, some from East Delhi, some from West Delhi, and some from Central Delhi. We try to pick different people. We try to have different genders represented, and then we try to have gather some information from that. So what do we try to do? Instead of talking to everybody, we just try to make a representative sample, ask them, and hope for the best that okay, these were the people that kind of have covered all the opinions and all the important points that we needed to implement that policy. So in order to deal with uncertainty and lack of information, we try to gather different data points using which we can make better decision. So statistics is nothing but using data points to make better decision, right? Using all the information that you have available to make better decision, right? To make better and informed choices, make better decisions. So that is the main purpose that we have, right? So the main purpose is to make better informed choices using whatever information you have available. Okay. So whenever we have uncertainty, how to make informed choices. This is the main purpose of statistics. So we try to analyze different data points. We try to analyze different sorts of results to make better decision. Okay? All right. So whenever we try to study something, what happens? There is a well-defined collection of objects. There is a very well-defined collection of objects, and we call that well-defined collection of objects as our population of interest. So, population of interest. So what happens? So a well-defined collection of objects is called some sort of population of interest. So let's say if I want to talk about some policy in Delhi, so all the people in Delhi, that is my population, right? Let's say if I want to make some policy for all the students in Delhi University, so all the students in Delhi University would be my population of interest. Let's say I want to make some policy for all the colleges that are there in India. So all the colleges that are there in India, that is my population of interest. So whatever I am studying, based on that, I will have a very well-defined collection of objects, and I will call that my population of interest. Okay, so based on what phenomena you are studying, based on what you are trying to get more and more information on, you will have different sorts of population of interest. So for every new scenario, for every new experiment, you will have a different sort of population of interest. Okay, so that is called population. Okay, all right. If you have information available on every single point in your population, then we call it a census. Do you know what a census is? Census of India. What does a census? So when we say census is going to happen, what does that mean in India context? Census 2011, census whatever. So this one was postponed because of COVID, right? So census mein kya hota hai? What happens in a census?
Information is collected from the people all over India.
So everybody, what happens every 10 years, this happens. And imagine why this is happening every 10 years, because it's so costly and it's at such a massive scale. It take 1, 2, 3 years to compile the data, to go in field, to collect data and all of these things, right? So census means you are going to every single village, talking to every single person and trying to gather information on various aspects. So because of this, not being so feasible, this is done every 10 years. At a gap of every 10 years, this is done for India. So what is a census? Basically, if all the information is available for all the objects in a population, we call it a census. So that is called a census. All right. So, okay, but it's practically not possible for us to always have the census available for the population, right? So what we do is, rather than collecting data on every single point in our population, we pick a sample. Okay. So now if I have to define a sample, how will I define it? So what is a sample? Subset of the population of interest is called a sample. So whatever population we had, if we take a subset of it, subset meaning, so if we have a set is basically a well-defined collection of objects, and you pick some elements from it, that is a subset, right? So a sample is nothing but a subset from a population. Okay. So, there are multiple ways in which you can pick sample. There are different methods in which you can do sampling. There is clustered sampling, there's stratified sampling, there is random sampling. Lot of different methods are there for sampling, but that is, discussion for some other time. Okay. All right. So also, before moving on, I think we need to discuss a few definitions. So let's try to understand what all those points mean. So first of all, what is a variable? So in terms of statistics here, any variable would mean what? It's any characteristic whose value may change from one object to other in the population. So we'll be talking about population all along. We'll be talking about samples all along. So in a population, what is a variable? So it is that characteristic value or some characteristic which will keep changing, which will be different, which can change from one object to other, right? So let's say if I'm talking about, some study that I'm doing for all the girls in Delhi University. So girl is not a variable because I have fixed that everybody is a girl in that population, right? So that is not a variable there. So let's say I study what are the different courses that they are taking. So that course is a variable there. Okay. So variable here would be any characteristic whose value may change from one object to other in the population. Okay. All right. We will be doing a lot of study related to different sorts of data. So what all kind of data we can encounter? First, we can have univariate data. So we can have univariate data sets. There'll be multiple data sets. Government also publishes a lot of data set. There are multiple private agencies which, publish a lot of data set on which people do research and everything. So what is a univariate data set? Univariate. Uni meaning one, variate meaning variable. So if your data set contains information only about one variable, it's a univariate data set. Okay. So it's basically a data set which consists of observations on a single variable. All right. So if there is something called univariate, then there is something called bivariate also. So it's basically a data set which contains data on two variables, right? So you can have bivariate data set. So whenever your data set has observations on, so consists of observations on each of the two variables. Then we can have multivariate data set. So it's a data set which contains on which each observation will have data on multiple variables. So multivariate data. So when do we have multivariate data set? When we have data available on different observation over multiple variables. Okay. So when observations are made on more than one variable. All right. So these were some basic definitions. Okay. Now we also want to talk about what could be the different. So what are the possible different ways in which we study statistics. So there is one branch of statistics that you have been studying so far from school and from whatever study that you've done so far. You've only understood different concepts related to one part of it, which is descriptive statistics. Okay, so there are basically two branches of statistics. First is descriptive statistics. And the other one is inferential statistics. Okay, so now what is descriptive statistics and what is inferential statistics? Okay, so as the term itself is trying to tell you, descriptive statistics. So what you are doing is you are describing the data. आप describe कर रहे हो data को, you're describing the data, ठीक है? So what you are doing is you're explaining what your data is, what is the mean, what is the median, what is the middle value, how spread is your data, how does your data look like, what are some important features of your data. So whenever you try to explain and present your data, that branch of statistics is called descriptive statistics. Okay. Now comes the other branch, inferential statistics. As the name is suggesting, you're trying to infer something. Okay. So in statistics, what you try to do is whenever we try to, so we basically want to have more and more information available with us. We do not have the population data available. So what we do is we try to pick samples. So what do we do with those samples? First, you can study that sample. You can describe what is the mean, what is the median, how variable is the data, how does the data look like, what are the important features. All of those things you will be doing in descriptive statistics. Now, what is the other part? Inferential statistics. So why did you collect that data on the sample? Because you wanted to know something about your population, but you did not have access on the population data. That is why you made your piece that, okay, this is the only data that I'm going to get. Now you want to say something about your population using this sample data. So you're trying to infer something about your population using the sample data. So, whenever government tries to implement some policies, they pick samples and they try to study whether this particular policy will be helpful or not. So what are they trying to do? They are picking a sample, they are doing that project on them. So it's like a pilot project, right? So they are testing everything there, and then when they are satisfied with the pilot project, then they implement it, countrywide or statewide or citywide, right? So what they are trying to do using that pilot project, they're trying to understand that, okay, this will work, so now let's implement it. So they inferred the success of that pilot project, that, okay, it will work everywhere. Okay, so that is the same thing that we do in inferential statistics, because we want some information about the population. So like, how are females doing in the workforce, how good are they doing? Okay, is a particular policy working well in the entire country? Okay, should we increase the tax rates or not? There are multiple information that we want to gather every day, right? So you can't ask everybody, you cannot gather all the information about the population, but you want to know about that only. So you pick a sample, you try to study it for that. When you do that, you try to say the same things about your population. So inferential statistics would be, using the information that you have from your sample to say something meaningful about your population. So that branch will be inferential statistics. So mainly, all these things that you will be studying later on. So like random variables and discrete random variables, continuous random variables, random sampling, and then, all the different topics that you will be doing in your semester 2 in your intermediate statistics course, they are all part of your inferential statistics. So these are all the tools that you will be using to infer something from the sample. Okay, and not just a mere description of it. Okay, So inferential statistics tries to infer meaningful information from samples about population. And descriptive statistics is describing whatever your data is saying. Okay. Just presenting it in good tables, good pictures, using important, summary statistics to explain what are the central numbers related to your data. All of that is descriptive statistics. Okay. So, yeah. So this is descriptive statistics and that is inferential statistics. Okay. There are multiple tools in the market. There are multiple softwares that could be really good in, doing all these statistics related stuff. So gone are the days when you used to do everything manually. So there is one software, R software. Have you heard of it?
Yes, ma'am. It is offered as an BAc in our college.
Okay.
It starts with R.
Okay. Okay. Are people opting for it? Is this a popular course there?
No.
No?
Yes, ma'am. Most of the students have opted that one.
Okay. Okay. That's nice. So, all the things that you will be doing, finding mean, median, mode, describing it, making charts, doing complex calculation, all these things. So, I mean, anything related to statistics, you name it, you can do it in this software, right? And then there are other softwares also. So there is one called SPSS. This is also where a lot of statistics is done. There are some programming language. Python, there's a programming language, Python. You can do a lot of statistical related libraries are there. You can do that. Okay. And then, there are some softwares, Stata, wherein a lot of econometrics is done. So like nowadays, lot of softwares are there to help you do everything. So your goal is to understand everything logically, conceptually, and things can be done in seconds, right? In a blink of a second. Okay. So, all right. So that is descriptive statistics. And inferential statistic would be when you try to draw some conclusions about the population using the sample information. So that would be inferential statistic. Okay. So, all the things that you will be later on getting to know regarding point estimation. Okay. Hypothesis testing. Confidence interval. So, all these topics, they will be covered under your inferential statistics. So right now, I mean, we will just be understanding the basic tools, but they will come later on in your second semester. Okay. All right. Fine. Okay. So what we have studied so far, that whenever we talk about inferential statistics, what we try to do is we have a population. We use some tools. We use some tools from inferential statistics. So we have a sample and a population. There are two things that we will always be talking about in statistics. One is sample and one is population. So what happens in inferential statistics? You take this sample data, you use some tools, and you try to make some claims about your population. So whenever we talk about inferential statistics, it goes from sample to population. Using sample information, you say something about population. Okay, all right. Can I ask you something regarding, whenever you study probability, so whenever you studied probability, how do we do things? So, we say that these are all the possible events that are there. Now tell me what is the probability of this particular event. So whenever we frame probability related problems, what do we say? That this is the experiment. So there is one experiment that is happening, that we are let's say we are tossing a coin 10 times. Okay, that is an experiment that we are doing, right? So tossing a coin 10 times. And then, so this is an experiment. So when you toss a coin 10 times, what happens? You can have head, tail, head, tail, head, tail. Different combinations can be there, right? And then the questions are asked in a manner like, okay, what is the probability that you have 5 heads in these 10 times? So then you try to figure out the probability, right? Or you can have all the population in Delhi University regarding the honors economics students. So let's say you have information about all the Delhi University students who are doing economics honors, and then you try to study what is the probability of people who are doing economics honors. So then what do? How do you figure out that probability? So out of all the people who are doing economics honors, you try to figure out what is the number of people who are doing BA honors economics. So there are major people who are doing major also. There are people who are doing minor also. So you just figure out the number of people who are doing just BA honors economics, and then you add all the people who are doing economics. So major plus minor plus honor students. So can you see the difference in how we are treating probability? So whenever we talk about probability, we always have information about population, and then we try to figure out the probability of picking a particular sample. So a particular sample was all the students who were doing the honors course, right? Yeah, a particular sample was only those possibilities wherein I had head 5 times. So a very important distinction that we have here is, in probability, we have information about population and we try to figure out the probability of the sample. So this is what happens in probability. So you have information about population. You want to move from population to sample. But in statistics, what you try to do is you only have information about sample and then you try to move from sample to population. Does that make sense? Right?
Yes, ma'am.
Okay, perfect. So whenever you do probability, all the population information is made available to you. So now when you read questions, now you see all the population data will be available to you. And then they will ask you, okay, what is the probability of this particular sample? Yeah, this particular event, which was a sample. Okay. All right. So if I want to summarize this, what I can say is, in any probability problem, population under study is assumed to be known. So it is assumed that the population is known, right? But in any statistics related problem, you know the characteristics of a sample, and then you make conclusions regarding the population. Okay. So this is the main distinction between any probability problem and any statistics related problem. All right. Okay, G. Is that all right so far?
Yes, ma'am.
Okay, G. Perfect. Okay. Okay. So now that we are clear with, like the most basic things. So what is population? What is sample? What is the purpose? What are the different branches? What are the differences between the two fields that we have? We would like to know a little bit more about, this part. So first we will try to focus a little bit here. So some tools related to descriptive statistics we would like to know. So we would like to know, what are the different methods in which you can understand where is your data located. So measures of location. What is the variability in your sample data, right? What is the variability? So measures of variability. What are different pictorial methods which you can use to describe your data? So all the pictorial methods that are there. So we would like to know a little bit more about this side. And then once we are done with that, we will be moving on to probability. And then we will be moving on to, the starting or the building blocks of inferential statistics. So we will be talking about random variables and all of these things. Okay. So this is how we will proceed. So first of all, let's try to put some time in understanding what are different pictorial methods that we have in statistics. Okay. What are different pictures? What are different methods pictorially that you can use to describe your data? Okay. So the pictorial methods in descriptive statistics. Okay. So what are these methods that we have? So first of all, before defining different methods, let's try to uh, look at the most common ones. So have you heard of histogram?
Yes, ma'am.
So we will try to understand what is a histogram, how to make a histogram under different scenarios. Okay. So there is something called histogram. Before learning how to draw a histogram, there are two important definitions that we need to understand. First is, what is a discrete data, or what is a discrete variable, and what is a continuous variable. Okay. So what is a discrete data? So any numerical value, a numerical value is discrete if, if the set of all possible values that your data can take, if, either it is finite, first thing, either it's limited, or if it's infinite, it can be listed properly. Okay. So a numerical value is called discrete, a numerical variable actually. A numerical variable is called discrete if the set of all the set of its possible values is either finite or it can be listed. It can be listed in an infinite sequence. So when do we call a data discrete? Either the data is finite. So let's say how many subjects that I can study in college. So 1, 2, 3, 4, 5, 6. Let's say my college restricts me to study maximum 7 subjects. So what is this data? This data is discrete because it's limited. Only 7 possible number of courses that I can take, right? So I can either take 1 course, 2 course, or 3 course, 4 course, 5, 6, or 7, right? The other possible, data could be, which is discrete. It's like, how many days I went to the gym in a year. So there is a possibility that either I go all 365 days, or I go to gym 0 days. Okay. So it can be anything from 0 to 365. So you can list it down like this, right? So these are all possible points that are there. So this is a discrete data. Okay. What if the data is not discrete? I mean, what if, these two types of examples that we studied, they are finite because the numbers that can be taken are limited, right? So 0 to 365, there are 366 numbers, limited. 0 to 7, there are 7 numbers. It's finite, right? What if we have some data which can be listed like this? Okay, 1, 2, 3, 4, and it can keep going on. Will that be a discrete data or not? So will we call that this is a discrete data?
Yes, ma'am.
Yes, because we can list it down in an infinite sequence, right? So although the numbers are infinite, I don't know how far this data is going, right? It's unlimited. It's till infinity, but it can be listed properly, right? So if you can write some data in form of an infinite sequence, then also it's called discrete, okay? So that is how we define discrete data, okay? The next possibility that we have is either your data is discrete or it is continuous, okay? So the second possibility that we have is, what if the data is continuous? So when do we call a data continuous? So any numerical variable, it is continuous if the set of all possible values is an entire interval. So it's an entire interval. On the lumber line, right? So if my data is something which can take all possible values in an interval, that will be a continuous data, right? So for example, let's say, what could be the possible height of people on Earth? What kind of data is this?
Continuous.
It's continuous because assuming, so we can have a data point which is what is the smallest possible height of any living person. So it can start with babies, so like their height, okay? And then we can also, in the Guinness Book record, we can see who is the tallest person, and all the people will have heights in between those two only, right? So any possible any possible height within this interval can be taken. So this is a continuous data, right? Or let's say, what could be the possible temperature in summers in Delhi? So is this a discrete data or a continuous data?
Continuous data.
Also continuous because whatever numbers that we have, let's say going from 25 degrees centigrade to, let's say, 50 degrees centigrade, it can take up any value, right? So although it's continuous, there is one point to ponder, but we only get to see that, okay, temperature was 45, 46, 45.5, only things like that. So doesn't that make it discrete? What do you think? So if even so, like this height example that we've taken, that's fine. We are saying that this is a continuous variable, but still, height can only be measured up to one any limit, right? So like whatever scales that we have developed, whatever scales humans have developed, only that much we can take, right? And it's always a jump, so we can always list it down, right? So now you confused me. Okay. So actually, if you think about it, the nature of it is such that this data is continuous, this height data is continuous, this weight data is continuous, this temperature data is continuous. It is continuous, right? But what is the problem? We as humans do not have the tools to measure them on a continuous scale, right? So like I have a scale, it can only measure centimeter. I have a scale, it can only measure millimeter. I might have a very precise scale which can measure micrometer. But I am bounded by limits, right? So it's because of my limits I'm not able to measure it. But actually, if you look at that particular thing, like measuring heights, it is still continuous, right? My height doesn't go from, let's say, 5 feet 3 inches to 5 feet 4 inches, right? Suddenly I will not become 3 inches to then 4 inches, right? It was a continuous growth that happened, right? So let's say if we collect data on how a person is growing, so that is a continuous phenomena, right? We grow it in our sleep also, but it's just that as humans, we do not have tools to measure it on a continuous level. So the way we measure it, it becomes discrete, but actually it is continuous, right? So are you getting the difference of where it is coming from? So it's because of our inability to measure them in a continuous manner that they seem discrete, but actually the nature of them is such that they are continuous. Okay. All right. Anyways, so we were talking about histograms. Okay. So now so we might have to make histogram on different sorts of things. We can have continuous data or we can have discrete data. So now if somebody asks us to make a histogram and the data is discrete, then we have different steps. And if continuous data is there and we have to make histogram, the steps are different. So that is why that distinction is important. Okay, so what do you do if you have to make a histogram for a discrete data? So, if my data is discrete for a discrete case, what happens? So, whatever data that would be given to us. So, for example, let's say we can take up some example. Okay, let's take some example. Okay, fine. Let's just cook up some example. Okay. All right. So let's say we have some data which is like this, that how many times a team wins. Okay. So there is a team and we are trying to understand how this team has performed. Okay. And, you know, uh, Narmada, just give me one moment, just a minute. All right. Okay. Coming back. So, let's say we have kind of a data on a team, and this team went on different tournaments, and how many matches they won in that particular tournament, that data is available to us. So one tournament they went to, they won 2 games. Then the other tournament they went to, they won 3. Then they won 4. Then they won 2 again. Then they won 5. Then they won 0. Okay. Then they won 2 again, 5, 4, 3, 7, 8, 6, 2, 3, 4, 5, 2, 1, 0, 8. So something like this. So all these are different tournaments that this team played, and what is the number of times that they won in that particular tournament against how many teams, that data is available to you. So this is a discrete data, right? Because it can be listed down and it's finite. So what do we do when we have to make a histogram on this? Okay. So what you have to do is, first you have to pick what are the possible X values that you have in this data, right? So what are the possible values that we see here? So we see value 0, we see value 1. So your possible values. So what are the possible values that we see here? We saw a value 0, we saw a value 1, we saw a value 2, we saw a value 3, we saw a value 4 also, and then 5 also, then 6 also, then 7 also, and then 8 also, right? So you list all possible values that you see. Now, what is the next step that you have to do? You have to write what is the frequency of any particular X value. So any particular X value that you have, of a variable, you have to write that. So frequency of any particular X value. So what is the frequency of any particular X value? It's actually the number of time that data has appeared. Okay. So frequency of any particular X value of a variable is the number of times that value occurs in your data set, right? So what is the number of times that particular value has occurred in your data set? So if I have to write what is the frequency here, what will I do? So how many times do we see 0? 1 and 2, right? So I will write 2 here. So just first write all possible values, then write all the frequencies. Okay, how many times do I see 1? We see 1 only 1 time. So 1. How many times do we see 2? We have here 1, 2, 3, 4, 5. So we see it 5 times. How many times do we see 3? 1, 2, 3. That's all, right? So 3. How many times do we see 4? 1, 2, 3. So again, 3 times. How many times do we see 5? 1, 2. 2 times. How many times do we see 6? Only 1 time. Okay, actually 5 we saw 3 times, right? 5 was here also. 1 and 2 and 3. So 3 times. How many times do we see 6? 6 we saw 1 here. Only 1 time. 7 we saw 1 time. And 8 also we saw 2 times. So you do it like this. So you list down all possible values that are there. And then you also list down what are the frequencies of that. What is the frequency? Number of times that particular value comes in your data set. Okay. So far, so good. Okay. All right. So this is frequency. There is another concept which is called relative frequency. What is relative frequency? How do you define relative frequency? So relative frequency. So relative frequency is actually nothing but whatever is your frequency to for a particular number, if you divide it by whatever is the total number of observations that you have. So these were the total number of observations that we had. If we divide a number of frequency with total number of observation, we get relative frequency. That relatively, how many times is this number coming? What percentage of time is this number coming in my data set? So everything get converted into percentages when you do relative frequency. Okay. So this is just this particular number. So number of times the value occurs in your data, which is basically your frequency. And then you divide it by number of observations in the data set. So when you do that, what do you get? You get relative frequency. Okay. So like if we have to calculate relative frequency here, what do you do? So, what is the total number here? We have to first calculate that. Okay. So you can just calculate. So 2 and 1, 3 and 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So total number here is 21. It should match here also. It will be a good checking that 4 numbers and 3. And then this is 3 times. So this is 21 only. So if I have to calculate relative frequency, I will simply do this. 2 by 21, 1 by 21, 5 by 21, 3 by 21, 3 by 21, 3 by 21, 1 by 21, 1 by 21, 2 by 21. This is what we will do. So that will give us a relative frequency. Okay, so now what do you do with all this? So the histogram will basically be nothing but you will be plotting on the x-axis. So what are the different steps that are there that you will have to follow? First, find your frequency. Steps for creating a histogram. Okay, what are those? First, find the frequency. And relative frequency. It's actually not necessary. Even if you just do frequency, that is fine. Relative frequency also fine. They will both give you the similar things. Okay. Now, for each x value. Now, what do you have to do? So this is, we are talking in terms of the discrete case. Okay. The next thing that you have to do is on your x-axis, on the horizontal axis, you mark all those possible x values. Okay. So mark those x's on the horizontal axis. Okay, so that's what you do. So like here, these are all possible values of x that we have. So we will mark all these values on the x-axis. So we will be doing this. So, what are the values that we have? 0, 1, 2, 3, 4, 5, 6, 7, and 8. So we have marked all these values, okay? On the horizontal axis. This is x-axis, horizontal axis. Okay, that's what we do here. All right, now what do you do? What is the next step? Above each value of x that you have, just make a rectangle of the height which is given by your frequency. Or just make a rectangle which is of the height of your relative frequency. Either you pick all frequencies or you can pick all relative frequencies. The choice is yours. So above each x, draw a rectangle of the height which is equal to relative frequency or you can say frequency of that value. So that's the only thing that you have to do now. Okay. So like above everything, just try to figure out what is the frequency, and then just you can draw a rectangle of this particular height. So against 0, this came out 2 times. So now we will just be putting it like this. So we have to make a rectangle of height 2. So we'll do something like this. So we can make something like this. Okay. So this is, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, something like this. So what we can do is, we can just make it, so 0 has to come till height 2. So, you can do it like this, till height 2. So this is till height 2. Okay. Now 1 has to come till height 1. So you can do this, till height 1. Okay, that's what you can do. After that, 2 comes till height 5. 2 comes till height 5. So that's what you can do here. So these are different rectangles that you're making. Okay, similar way you can proceed in all the others, right? So 3, 4, and 5 are all 3. So 3 and 3 and 3. And then 6 is 1 and 1. So this is 1, and then this is 1, and then the 8 one is 2. So this is 2. So that's what is going to happen. So this particular diagram that we have created, this is a histogram for this particular data set. Is that all right?
Yes, ma'am.
So frequency, make a frequency, list down all possible values of x, make frequency or relative frequency, plot all the possible values of x on the horizontal axis, and then make rectangles which are of required height. Either you can take frequency or you can take relative frequency. Both are fine. So if question asks you specifically for relative frequency, you can use these numbers that are there. And if they ask you to do frequency, then you can just follow these. Okay. Using frequency is always easier, but if they specifically ask you to go for relative frequency, you can do that also. Okay. So this is how you deal with discrete data. So this is how we will be talking about the discrete version. Okay. So far, so good?
Yes, ma'am.
Okay. Now let's move on to the continuous version. Okay. Now what happens in the continuous version? If your data is continuous, so it's not like different finite numbers that you can put your data into, right? So whenever you have continuous data, what are the steps that you have to follow? That is an important challenge. Okay, so what are the steps? So first, what you have to do is, whatever data that you are given, so what you have to do is, you have to divide the data into different categories, into different classes. So you divide the data into subclasses of equal width such that every possible value fall in exactly one interval. So, you are given some continuous data. So you have to now think about how will you categorize your data, right? So now you have to think about, okay, how do I divide my data into smaller pieces so that whatever possible values, whatever possible data points I had, they fall into exactly one single interval, right? So every possible value has to go only in one interval. One possible value cannot go into different classes, right? So what does that mean? For example, let's say we have what kind of data? Let's say we have data on height of people, okay? Height of 20, not 20 will be a too big a number. Let's say height of 12 people. So let's see what are those heights, okay? So let's say we are talking in terms of centimeters only, okay? So 150.5 centimeters. Then everything is in centimeters, so I'll not repeat centimeters again and again. So this is centimeter, okay? 150 centimeter, 150.5 centimeter, 155 centimeter, 152.3 centimeter. Okay, 152.3 centimeter, and then 154 centimeter, okay, 151.8, 153.9, 160 we won't be doing, 150, 155, 152, 153.8, 154.9, 156. So let's say these are different heights of people that we have, right? So height is obviously, these are not specific numbers. Height is a continuous data, right? So now we have to divide this entire data into different classes, okay? All right. So now our goal is to divide it into classes. So, earlier when you used to be in school, you were given all these categories and then you had to do these things, right? Now here you will be dividing and making different categories. Okay. So let's say, using this data, we have to understand everything. Okay. So divide the data into subclasses of equal width such that each possible value, every possible value is falling in exactly one interval. Okay, so, and how do you do that? As a convention, whenever we make any interval, in any interval, x2, x plus h, if let's say I write this interval, so let's say if I write 150 to 153, if I make such an interval, so as a convention, what is understood automatically, unless you say something else, is that x is a part of this interval. And this x plus h is not a part of this interval, okay? Right? So if I write this now, if you see any interval like this, so that means 150 is a part of this interval and 153 is not a part of this interval. This is the convention that we follow, okay? So if you see 150 anywhere, you will not put it in this interval. So you will not count it here. You will count it in the next interval, okay? So that is a convention that we have. So if you see any interval like this, x2, x plus h, x is a part of it. This is a part of this particular only, and x plus h is not a part of this interval. So 150 is included, 153 is not included. Okay. So let's say we divide this particular data in this manner. So what do you have to do? We have to create possible different classes, each of equal width. Okay. So let's say here, we have numbers from 150 to 156. Okay. So what do we do then? How should we, make different categories? What can we do? So can we take numbers from, 149 to 149? There is no need actually, because we do not have 149. Let's pick 150 to Okay, let's do one thing. Let's do 149.5 to 156.5. Can we do that? So the starting point we can take 149.5 till my intervals can go till 156.5, right? Does that seem fair? Okay. Now you see what are the different numbers that you have, how many jumps we can take. So, what we can do is, so this is 6.5 and 0.5. So we basically have 7 different jumps that are there. Okay, wait, let's not do that. Rather than 7, let's do this. We can do something like this. Let's do this, 157.5. Let's do that. So that we have a total of 8 gaps, and then we can do a jump of 2, right? So one value could be 151.5. The other value could be 153.5. The other value could be 155.5, right? So I have divided everything. So this is my starting point. This is my ending point. And these are the different intervals that I have created. So I've created 4 intervals. Okay. So what are my intervals now? Going from, yes, I'll just add it here only. Yeah. So class intervals. Okay. So what are the different intervals that we have? We have 149.5 to 151.5. Okay. That is one. What is the other one? 151.5 to 153.5. Then what do we have? 153.5 to 155.5. And here we have 155.5 to 157.5, right? So these are 4 intervals that we have used, and we have to, and all of these are of equal width, and their width is 2, right? How do you find width? Just the upper value minus the lower value. Okay. So now once you've made the class intervals, now we have understood what is the convention also. The left side point is included. This is not included. Okay. So that's how it is. Now we have to repeat all the steps that we did in first part, like the discrete case. So after you divide it into different class intervals, now you have to create frequency and relative frequency. And then again, steps, horizontal axis, make these intervals, make those rectangles. That's all. So again, repeating all the same steps. Okay. So fine. If we create frequency, what happens here? How do you make frequency here? So what are the numbers that are from 149.5 to 151.5? So what are the numbers? So this is included here, right? What else? 150 is also included. What else? Nothing else, right? This is also not included. This will be a part of the other interval. We can take 150 to 155, but like this data was so small, because if you would have taken such a big interval from, let's say, 150 to 155, almost everything would have been part of that only, right?
Yes, ma'am.
So, so like out of those 12 values, 10 values would have been a part of 150 to 155. And then let's say 155 would be a part of the other one, and 156 would also have been a part of the other one, right? So typically, how do you decide like how many class intervals that you have to make? So there is no hard and fast rule. Here we've made 4 intervals. You could have made 3 also. You could have made 10 also. Anything is possible. It's not about possibility, but a good rule of thumb is, how do you decide? So how many classes that you can make? Number of classes. is basically you can do square root of your number of observations. So when you are not able to decide, what do you do? So typically, you know, any number of class intervals from 5 to 20 seems fine. And if you seem confused, you can apply this particular rule. This is, I mean, this is just a convention. So here we had 12 observations. You can take a square root of 12. So square root of 12 is something which is greater than 3, right? So you can take 4 or 3, anything. If you're 25 observations, you can divide the entire data into 5 intervals. That's the logic that you can apply. Okay. But even if you do 5 or 6, it won't matter. Okay. Is that all right?
Okay. Yes.
And in your exam, it's very specifically written that you will not be asked to draw a histogram. You will be asked to interpret, and any kind of analytical questions can be asked from that particular topic. Okay. So, but it's a good idea to know how to draw all of that. Okay. All right. So fine. Now, so for this interval, our frequency was 2. For the other one, for the next one, how many times, like what is the number of time? So this will be a part of this interval 1. And 152.3 will also be a part of it. 152 will also be a part of it. And that's it, right? So we will have 3 observations here. Okay. Similarly, 153.5 to 155.5. This will be a part of it 1. This is 2nd. This is 3rd. And this is 4th. And this is 5, right? So we have 5 points from this interval. So 5. And then rest, you know, 150.
154 is also.
Oh, yeah, I skipped that also. So 154 is also there. So actually 6. Yes. Right. And again, here, what do we have? 156 will be a part of this one. So now you made it like this. And then now you can make relative frequency also. Now what you have to do is you just have to use the horizontal axis again and, you know, plot these points, make the rectangle, and each rectangle will have a height according to frequency, and their width would be 2 units, as is the width here. Rather than, you know, rather than doing these 0.5, 0.5, 0.5, you could have done this also. You could have started from 150 till 157, you could have gone, right? From 150 to 157. Or so things like that you could have done. So no issues regarding that. Okay. So we could have done this also. So we could have started from, let's say, 150 and went till, let's say, 158. You could have taken a jump of 2 units, right? So 150, 152, 154, 156, and then 158. You could have done that also. Okay. Anything is possible. So there is full flexibility over there. Okay. So now once you're done with that, then you can just plot it. And let's say on the horizontal axis, you write these things. 149.5 to 151.5. All these numbers you plot, and then you make appropriate rectangles, and that will be it. Okay. Are we good with that?
Yes.
Okay, so we find the frequency and then make the rectangle of height equal to frequency or relative frequency. And then in case we are not able to decide how many classes we want, we can use this particular formula. Okay. All right. Okay. Narmada, I think let's take a break now, and then we will talk about another kind of histogram wherein we do not have equal class width. What could be the possible reason why we may not want an equal class width? What could be the reasons for that? And we will see how to make the histogram whenever our class widths are not equal. So like here, we had 2 units, 2 units, 2 units, 2 units. Every class interval is equally spaced. So what if that is not equally spaced? How do we go about doing that? So we will talk about that. Okay. It's 7:17 right now. Let's resume at 7:27. Okay. Thank you. So now we have to talk about how to deal with making histograms whenever, there is a data which is a little bit concentrated. Okay. So what if we have some data which is not equally spaced? Okay. Because there could be circumstances under which your data is a little concentrated. So let's say, your data could be of different sorts. So let's say this is a number line. I have my data point here, 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 and then I have some data points here, 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 and here. So here, what do you see? Most of the data points are centered here, like at this place, right? As opposed to some data point which looks like this. Some points here, 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 and then here, 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 and then here, here, here. This looks like a more equally spaced data, right? So things are not very, very concentrated. So whenever we have a situation like this, it's not usually a good idea to, make those class intervals like this, that, okay, this, and then, okay, this, and then, okay, this. Because what will happen, if you try to make your class widths equal, what will happen? Some will have so much data. So whatever class width, class interval we will have here, it will have all the data. Here, no data. Here, very less data. Here, very less data, right? So whenever we are in this situation, what we try to think about doing is we try to make different class intervals. That's what we plan to do. Okay. So whenever a good choice in a highly concentrated data is to use few wider intervals. So take few intervals which are a little wider, right? And then there are other few which are a little smaller in size. Okay. So we use few wider intervals where the data is limited, where the data is sparse, meaning limited data, and many smaller intervals wherever the data is concentrated. So like we can have different sorts of widths, something like this. So, we can have a width which is of this size, and here we can make three smaller, class intervals, and then I can make a big one here. So we can have a histogram like this. So one is this, one is this, one is this, one is this, and one is this. So these are the different intervals that we can create. So wherever we have less data, we can have a very big wide interval. Wherever we have lot of data, we can divide it into smaller intervals. And wherever we have, again, limited data, we can have a big wider interval there. So that will be a histogram wherein our class intervals are not of the same size. They will have unequal width. Okay. So what happens there? Can you give me an example of a data wherein, you see such things happening? Any example? So, let's say your class has 50 students. Okay. And there might have been some paper exam that you might have given. And what is the number of marks that what are the marks that people get out of 100? How many people, there are very few people who will score like above 95, right? There are very few people who will score less than 5 marks, or very low number and very high number. These two numbers, like number of students will be scoring very high and very low will be small, right? Most of the people will hover around in the average, in the middle somewhere. Yes or no? That's typically what happens, right? So that is some sort of a concentrated data where majority of the concentration is in the middle, right? Majority of the people will be scoring 60, 70 or 50 or something like that, right? Very less people will be scoring two lesser mark, like less than 20, very few people, right? Or less than or greater than 90, very few people. I mean, unless the paper was such that everybody was scoring very, very less, or the paper was so easy that everybody is scoring too much. But typically, this is the situation that we see, right? In any exam, most of the people range in between, very less people on the lesser marks and very less people on the higher side as well, right? So that could be a possible example for a highly concentrated data. Okay, in that case, you can use such histograms. Okay, so what happens there whenever your class widths are unequal? Then what do? You have to do the following. What? In case of unequal class widths, the only thing that changes is you have different intervals that are there. You have to make those same intervals, whatever intervals you're making on the histogram, on the horizontal axis, right? The only thing which changes is you do not use frequency and you do not use relative frequency anymore. Now you are using density. Okay, so how will you determine what is the height of the rectangle? So rectangle height, how do you calculate what should be the height of rectangle? It should be whatever is the relative frequency of that particular interval of that class. You have to divide it by whatever was the width of that particular class width. So whatever is the relative frequency of a particular class and divide it by class width, whatever is the width of that particular class. When you divide that, that is the height of the rectangle that you will be taking. Okay, and this rectangle height is basically, would be called density. Okay, so sometimes histogram would also be called a density scale if you have something like this. Okay, so whatever is the rectangle height, that will be the density. So whatever is the relative frequency of that class, and you divide it by the class width. Okay, so for example, let me just grab one example that we can have of something like that. So okay, let me see this. Okay, so let's say if we have some data like this. Okay, so if we have some data like this, what do we see here? Most of the values that are there. So here, 2 to 4. So this is basically all the points that were there. And then they have been divided into multiple classes. So one class is 2 to 4. And this symbol tells you what? That 4 is not included. What does this symbol tell you? 6 is not included. 8 is not included. 12 is not included. 20 is not included. 30 is not included. Okay. So, all the data points which were from 20 to 30, that was very small, only 2 data points. So like very big numbers were very small. So they had a interval of width 10 and it had only 2 values. So the class width here is 10. The class width here is 8. The class width here is 4. The class width here is 2. The class width here is 2. And here again it is 2. Most of the data points are lying on the left side, right? And here very few points are there. So they have taken wider intervals, right? They've taken wider intervals. Okay. So frequency, they have calculated from here, and then they have calculated relative frequency. And this particular density number that we have, this density number is coming how? whatever is your relative frequency, you have divided by class width. Okay. So whatever is the difference between this upper value minus lower value. Okay. So that is how we've calculated densities. Now, what are you supposed to do whenever you have to make a histogram? You will be using these intervals. You will be using these intervals to plot on the horizontal axis, and on the the vertical side, the rectangle that you will be making, they will have a height of this. This is the height that you will be using. Okay. So, if you kind of see how this looks like, it looks like this. It will look like this. This is how it's going to look like, right? So, 2 to 4, and then 4 to 6, and then 6 to 8, and then a wider interval, then even wider interval, and then a very wide interval, right? And then they have different densities that they've plotted from here. Okay. Can you tell me what will be the area of any rectangle that you pick from here? What will be the area of rectangle in this case?
Density into class width.
So density into class width, and what will that give you?
Relative frequency. Yes.
So the area of the rectangle that you're saying, that it is the density multiplied by class width. So if I multiply by density multiplied by class width, what do I get? Relative frequency, right? I'll be getting relative frequency.
Yes.
Right? Because you see here, because this density was calculated how? Dividing by relative frequency divided by class width. So if you multiply this side, you'll get relative frequency. So in case somebody just gives you this diagram, doesn't give you anything else, you can still calculate the relative frequency, right? By finding the area of the rectangle. So whatever is the relative frequency at each of the places, each of the interval, you can simply find what is the area of each of the rectangle, and you will have your relative frequencies with you. So sometimes, some question like this can be asked. So just be a little careful there. Okay. Is that all right?
Yes.
So that is good. All right. Moving on. Okay. Okay. There is one more extra nice feature that we have. These are different relative frequencies that are there, right? If you add all the relative frequencies, what do you get?
1.
Yes. So if we add all the relative frequencies, we will be getting 1. Okay. So if you add all this area together, you are going to get 1. Right? So sometimes if they ask you questions related to, what is the proportion of people who have, something from 4 to 8, then what you have to do? You have to deal with things in terms of relative frequencies. So like, what is the proportion of people who've scored 90 marks? Like, what is the proportion of people who've scored marks less than 90? Okay. So you have to find all those intervals wherein the marks are less than 90, add all those relative frequencies, whatever number you are going to get, that will tell you that appropriate proportion. So relative frequency is actually nothing but a percentage. So here, what does this mean? This means that 18.75% of data points are in this interval. This means 31.25% of data points are in this interval. So here 10%, 10.42%, here 18.75, here 16.67, here 4.17. So relative frequency tell you something more about proportion and percentages. Okay. So you have to deal with it like that. All right. So far, so good.
Yes.
Okay. Hi, Anshika. Good evening.
Good evening, ma'am.
Okay. All right. Moving on. Okay. So, ठीक है, ये तो हमने देख लिया. We've seen this. Okay. So now you can have different sorts of histograms, right? You can have histogram. So this particular histogram that we saw, it looks like this, right? if we try to join everything, right? We can have, a histogram which looks like this, different rectangles. So if we try to join these peaks, it's something like this, right? We can have a histogram which looks like this, right? We can have a histogram which looks like this again, like if we join all those points, right? So what does that mean? There are different terms associated with it. So, you call it unimodal histogram. What is a unimodal histogram? A histogram which has a single peak, which has a single peak. Single maximum value. If some guys, I'll just have some water. Just a minute. All right. Okay. So you can have a histogram which has a single peak, right? Something like this. If you make rectangles like this, it had a single peak, right? So this is unimodal, right? Sometimes you can have two peaks, right? So then it will be called a bimodal histogram. Sometimes, it may not even be the case that you only have two peaks. It can have multiple peaks. Then it will be called multimodal histogram. And it actually kind of also depends on what kind of intervals you have taken. If you take too many intervals, if you take too many small intervals, there will be very few data in each of that, and then you might have a multimodal data, right? So basically what kind of histogram you are going to get, it also depends on your choice of class intervals. So it also depends on your choice of class intervals, what kind of histogram you are going to get. The modality, whether there is single peak, more than one peak, multiple peaks, that will depend on choice of your class intervals, okay? So the larger number of classes that you will take, it is likely to result in multimodal histogram. Okay, so if you take large number of classes, it's likely to have something of this sort, something like this. This will keep happening, right? I'll show you like in some like 5-10 minutes. I think in next 5 minutes only, I'll just show you how this will come into being, right? How we can see this happening. So I'll show you a Google sheet, and we can see how histogram looks like there, and how if we change the class interval, how will that affect our entire analysis? Okay.
Ma'am, is there any criteria? Means in this number of classes there will be bimodal, or in this number of classes there will be unimodal?
No, there is nothing like that. Nothing like that. So all we are trying to say is कि आप जितनी ज़्यादा, the more number of classes that you will make, क्या होगा इससे कि आपकी हर whatever class interval that you're taking, because if you make larger number of intervals, whatever is the number of data that you can get in each interval, that will become smaller and smaller, right?
Yes, ma'am.
So like, when we had a data like this, if, we had intervals like these, so here till here, and then till here, and then till here. So here we had 5 points, here we had 4, here we had, 4, here again we had 4, right? So there was one peak which was 5. If you try to break it down even more, right? So rather than doing this, you do this, that okay, this, and then this, and then this, and then this, and then this, and this, and this, and this, and this. What happens? In every single interval, you've broken down everything. So the number of points that you have in each interval will go down. So the chances are you will see multiple peaks, right? So here you have one data point, here you have two, here you have two, here you have two, here you have one, here you have one, 1, 3, 2, and then 2. So you had 1 and then 2, 2, 2, 2, 2, and then 1, 1, 1, 1, 1, and then 3, and then 2 and 2. But this is not how you will draw it, right? तो क्या हो गया, जब आपने बहुत सारे क्लास इंटरवल्स में चीजें डिवाइड कर ली, तो हर इंटरवल के अंदर कम कम एलिमेंट्स जाने लग गए. तो उसकी वजह से क्या होगा, इट्स लाइकली दैट यू विल स्टार्ट सीइंग थिंग्स लाइक दिस, राइट? That is what is happening. So there is no criteria that if you have these many intervals, it's unimodal, bimodal, nothing like that. It totally depends on the data. Okay. Is that fine?
Yes, ma'am.
Okay, perfect. All right. So there are some other terminologies also which will be relevant for you, which is first is, so what kind of data we have? So symmetric hai ki nahi, data, whether the data is symmetric or not. So symmetry, what does symmetry means? Symmetry means there's some pattern associated with it, right? So like we find lots of symmetric things going on in nature, right? So what does a symmetric data mean? So let's say if you have a diagram like this shows na that, we have one point, this, whatever is happening on the left side of this, exactly similar things are happening on the right side of this, right? So there is symmetry, right? So if you keep a mirror here, yahan pe there's a mirror, right? So whatever is happening here, exactly same thing will be visible here, right?
Yes,
There is symmetry going on. So that is the logic that we are following. So here, if you see, whatever data you have here on the left side, similar pattern is being followed on the right side. So such kind of data will be called symmetric. Okay. So a histogram is symmetric when left side and right side are exactly similar. Okay. All right. What could be the other possible cases when your diagram looks like this? So let's say you made a histogram and it looks like this. They're okay. It's like this. So it has a very long tail, right? It's not symmetric, first of all. There is no pattern associated, right? Whatever point you pick, here we have different, here we have different. Whatever point you pick, here this is different, here this is different. There is no symmetry, right? So this is not a symmetric data. Second thing, this can be considered a tail for this particular diagram. It has a very long tail going on, right? Very long tail on what side? Right side. So we call it a positively skewed data. Okay, positively skewed data. A lot of data is available on the positive side, right? It has a very long tail on the positive end, on the positive side. So this is basically, positive axis, this is negative axis. So because of this, we say that, okay, this is positively skewed data. Okay, this is called positively skewed data. What does the term skewed means? Skewed is generally used in terms of, whenever you want to say that kind of biased hai, this is biased, the audience, the judges were skewed towards that particular contestants, the judges were biased. So these are the terms that we use, right? So whenever somebody is more influenced towards somebody, we call that the results were skewed, or, the result were not unbiased. So those kind of terms are being used. So here This particular diagram is more skewed towards the right side. That's why you call it a positively skewed data. Okay. So if histogram comes like this is a positively skewed data. The other pattern that we could have is something like this. We could have a diagram like this. Is that okay? It's something like this, right? So it has a very long tail on this side. And what is this side? This is negative side, negative x-axis side. So that's why we call it a negatively skewed data. We call it a negatively skewed data. Okay, so we call it negatively skewed data. Okay, so if I have to define it, symmetric means if the left half of the histogram exactly looks like the right half, it's symmetric. Positively skewed means if right tail is stretched out as compared to the left tail, then it's called positively skewed. And if the left tail is more stretched out as compared to the right tail, then it's called negatively skewed data. Is that all right? So far, so good?
Yes, ma'am.
Okay, all right. So far we've only talked about quantitative data, right? So wherever there are numbers, then it's discrete, it's continuous, right? But it's not always necessary that in statistics you will only see numbers or quantitative data. We will have a lot of data which is qualitative also. So like what is the gender of a person? That is a category, right? So that is not a number. Okay, what is the place? Yeah, or you can say which state are you staying in, right? Which state or union territory are you born in? So that is not a number, that is a category. Okay, so what is the level of education that you had? So class 10, class 12, undergraduate, postgraduate, PhD, more than that, different categories are there, right? What is the, let's say, anything could be a qualitative data. Okay, so basically whether you're married or not, whether anything. So different sorts of qualitative data are also there, right? So how do you make histogram in that case? So first of all, you simply can do the following. So like, let's say if you have some data on different categories, and those categories are A, B, C, D, and E. So what you can do is simply do this, that you can write A here, B here, C here, D here, E here. And then whatever is the frequency in each of these, you can just plot a rectangle like that. So you can do that. That is one thing. And if there is some natural ordering to something, so, okay, so natural ordering could be, let's say we have data on which income bracket do you fall into, right? So whether you are a lower class person, like in terms of income, or you are middle class, or you are upper class. So there is a natural ordering, right? So either lower, middle, upper, or upper, middle, lower, right? It makes sense to order it in this manner rather than just saying lower, upper, and then middle, right? So there is some natural ordering here. So whenever you plot a graph, first you will do this, and then middle, and then upper, right? So whenever there is some natural ordering, you follow that ordering. If there is no ordering as such, you can just put any category anywhere, right? So if you're just putting gender data, male, female, or other categories as well, right? Male, female, transgender, other, or different categories that are there, right? Place of residence, urban, rural, different things like that. Okay. And like, what is your level of education? So have you studied till 10th, and then till 12th, undergraduate, postgraduate, PhD? So there is some natural ordering which is associated with it, right? So you can't move to the next one before doing that. So you should order your data in this manner whenever you're making a histogram like this. Okay. So in qualitative data, if you make histogram, if there is some natural ordering, follow that. If there is no natural ordering, just put all the categories, just write whatever frequencies or relative frequencies that you have, and then that's all that you have to do. Is that all right?
Ma'am, do we have to plot the frequency or relative frequency on the y-axis?
So if you have see, if you have first different categories are there. अगर आपके पास, if you have a data wherein the class intervals are not unequal, so they are equal, then it doesn't really matter whether you write frequency or relative frequency. Or if you have discrete data, then also it doesn't matter whether you write frequency or relative frequency. If you have qualitative data also, it doesn't matter whether you have frequency or relative frequency. Only in one case it will matter. There you anyways don't write frequency and relative frequency. There you plot the density whenever the width are unequal. So only in case of histograms with unequal width, you plot the densities. Rest everywhere it's fine. I mean, frequencies will also give you the similar thing, similar pattern. Relative frequency will also give you the similar pattern. So if they specifically ask you to do something, you can follow that. Otherwise, whatever you do, whether frequency or relative frequency, it won't be wrong. So they are both correct.
Okay, ma'am. But if there is discrete, for example, A, B, C, D,
Yeah.
so we can put both the frequencies on y-axis.
Yeah, like you can write frequency also. That's fine. If you write percentages, that's, I mean, relative frequency, that is also fine. So more like it's a convenience point that, you know, if you have lots of numbers, very, very different numbers, relative frequency tries to bring everything down to one scale from 0 to 1. So, you know, this is exactly, you know, like from 0 to 1, only the numbers are going to be there. But if the frequencies could be like 8, 20, so a lot of variation in your y-axis. So as a matter of convenience, you can do relative frequency because everything will be from 0 to 1 only, right? So it gets scaled up. Okay.
Okay.
All right. Okay. Guys, any doubts so far? All good?
Yes, ma'am.
Okay, perfect. All right. So there are two small things that I have to do, which is first, or maybe, okay, it's fine. Let's do it in the next class. So there was stem and leaf diagram and dot plot that was there. So we'll just do that in next class. And in next class, we will also start talking about what are the different measures of location, mean, median, mode, trimmed mean, all of those things. And then we'll also start talking about measures of variability, like range, what is quartile, what is percentile, what is standard deviation, what is variance, all of these things. And then there are few more pictorial methods. So there is something called box plot, which tells you a lot about variability, how variable is your data. So when we discuss measures of variability, we will discuss that also. Okay. All right. So, all right. Okay. I think let's do that in the next class. So which will be on Thursday. And guys, do you have a holiday tomorrow for your college?
No, ma'am.
No, and not on 31st also?
31st, we are our classmates are planning to
Mass bunk.
planning for a mass bunk, ma'am.
Okay. 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 All the very best for that. Okay. Thank you. Take care, guys.
Thank you, ma'am.
Thank you so
Thank you.
much. Bye-bye.